This is the composite figures practice test, and this can be used to study for your test on Thursday. Number one, the front, top, and side views of a three-dimensional figure are shown below. Which could be the three-dimensional figure represented by these views? Okay, so I like to pick one of the views and kind of focus on it and then start eliminating some of these. So if I look at the top view, I see that it should have this kind of U shape to it, which if I'm looking down at each of these, it could be this one, could be this one. This has a U shape, but not long enough. So not that one and not this one. All right, so looking at the front, I once again have kind of a U shape. So going back over to my front view, I see that this one does not meet that criteria. This one does, and then these I already eliminated. Could have been this one, but I already eliminated it. And then if I'm looking over at my side view, once again, it's kind of a sideways U picture, which again, I see that this one fulfills all of those. So there's your answer. Number two, this is a similar question where you need to determine the views that you're seeing. These are drop-down menus that just give you the choices of top view, side view, and front view. So I need to figure out what view I'm looking at for each of these menu items. So I can look over here and I see that this area is labeled as my front view. So I'm going to kind of start there. So it should be that U shape. So it looks like it's going to be this one as my front view. Okay. Then if I look over at my second one here, I've got kind of this little shape here, which I see matches with these over here. So that means that's going to be my side view. Okay. And that kind of just leaves this one to be my top view. And that one's a little bit harder to see, but I can see that if I change my color here, I can see that it sticks out here. And so there's two along the side and then another one over here and here. So that should fit with my top view. Number three, Little Green Mini Golf is laying new artificial grass for their course. How many square feet will they need to cover the shaded area shown? Okay, so being that it says to cover the shaded area, I'm going to be looking for the area of this figure. And before I start, I'm going to need to cut it into a couple of different pieces in order to figure this out. So I'm going to cut it here, which means that I'm going to have a rectangle that is 6 by 13. I have a triangle with a height. I can see that this height is 5. Okay, and I'm gonna have to figure out what the base is. Let's see, if I scoot across the other side of this rectangle, it gives it away for me. So this base is going to be 6. So this other red line is 6. So now let's kind of just figure out, we're going to have to figure out the area of the rectangle, the area of the triangle. Then it looks like I'm going to have to, I've got like a hole in here that I'm going to have to delete from there. Okay, so 6 times 13 for my rectangle is 78. So I'll just call that shape 1 is length times width, 6 by 13, and that's going to be 78. My next shape is a triangle, so it's 1/2 base times height. My base is 6, my height is 5, and of course I have to multiply that by 1/2. So I can, and you can punch that in your calculator one of two ways. You can put in 1/2 times 6 times 5. Or you could put 6 times 5 and then divide it by 2. And that's the same thing as dividing by 2 is the same thing as multiplying by 1/2. So let's see, 6 times 5 times 1/2 is 15. Okay. And my third shape, which is actually going to be subtracted later, that's just a square, is length times width. 3 times 3 is 9. And I'm going to subtract that one later. So I need to add up the 78 plus 15 is 93. So that's the area of all my green, but that also includes this because it's right in the middle of it. So in order to get rid of that, I just need to subtract it away. So I'm going to go 93 minus 9, and I get 84. So I would just fill in 84, and the problem already has the feet squared, so I don't need to add that as well. What is the area of the parallelogram shown below? So parallelograms are one of the shapes that you're given on your formula sheet. So this one's pretty simple. It's not actually a composite figure. And if you look at your formula sheet, you're going to see that it's A equals base times height. And so I'm going to use this 65 as my base, and my height is 40. And these are just as simple as that. You don't actually need to divide it up into triangles and rectangles. You don't need to do anything else because I've already been told that this is a parallelogram. So it's 65 times 40, and I get an area of 2,600. This says to find the area of the trapezoid. Once again, this is not a composite figure. This is a standard shape. It's a trapezoid. So I can look up on my formula sheet, find the trapezoid, and use that formula to find the area. So it's area equals 1/2 height times base 1. Oops, meant to just be 1 plus base 2. All right. So my height is this 4 feet right here. So it's 1/2 times 4. And then my bases are just the two parallel lines in the trapezoid. So it would be 6 plus 10. And you can enter it into Desmos just the way that you see it there. 1/2 times 4 times 6 plus 10. Make sure you include the parentheses for the 6 plus 10. Otherwise, you may end up with mistakes. So I get a total area of 32. So that'll be 32 feet squared, my second option here. So this problem starts to get a little bit more complicated. We have a nice composite figure here. It says the YMCA must cover its outdoor swimming pool with a vinyl tarp. How much vinyl is needed to make the tarp? Round your answer to the nearest whole number. So I'm looking for area. A couple of hints there. It's going to cover the whole thing, so that means that it's got to cover all of it. That's area. I also look at my possible answer choices, and they all have that little 2. That means that they're measuring this in meters squared, which is how you measure area. When you're measuring linear feet, you won't see the units squared like that. Okay, so we're looking for the area of this, and I can break this into, I've got 2 semicircles, and they have the same diameter. So I can really kind of just pretend that I've got one whole circle here. Okay. And then I also have in the center a big rectangle. So it looks like my rectangle, I'll call that shape 1, and then my circles, I'll say that's shape 2. So number 1, I've got a rectangle, so that's length times width, or 30 times 60. And I'm going to put that in my calculator. 30 times 60, I get 1,800. Okay. My second shape, that's going to be a circle, and make sure you're using your formula chart. So under the circle, I see 3 different formulas. 2 of them have C equals. So C equals 2 pi r and C equals pi times d. That's looking for circumference, which is really the same thing as perimeter. So those aren't the right formula for me. If I use that formula, I'm going to get the answer wrong. So I need to make sure that I use the area formula. I know I've been given the diameter, and so it's very tempting to just say, oh, well, I'll use the one that has the pi and d. But the problem is that that's a circumference formula and not area. So I have to use this A equals pi r squared, okay? And I'm pretending I've got one circle, because if I were to put the 2 of these together, I would get the area of one circle since they have the same exact diameter. So here it's going to be pi times r is going to be 15, because they gave me the diameter, so I got to cut that in half to get the radius. So it'd be pi times 15 squared. So I'll go ahead and put that in my calculator and use 3.14 for pi. So I get 706.5 and then add 1800. And I get 2506.5, which rounds up to the nearest whole number would be 2507. So that's your answer right there. All right, next problem. The gym teacher is setting up for a field day event where students will run blindfolded through a series of obstacles. To prevent injury, she will enclose the area with a nylon fence, which can be ordered from Lowe's at $10 per linear yard. How much will the nylon fencing cost? So don't be fooled by the word area here. They are talking about a fence which goes around the area here. So we're actually looking for the perimeter of this figure. And the tricky thing with this figure is we need to make sure that we include all of the different parts. So I can see I've got this side. I've got this side is 9. This side is 4. This side is 15. So I'm missing, it looks like just these two sides. So I'm going to just, one thing that I find useful is matching up the sides. So I can see this blue side plus this blue side add up to make this side over here. So this side over here is going to be 9 plus 4, which is 13. And I'm going to change my color again. And this other missing side that I've got here is, if I were to combine this with this, it would equal this other side. So your sides kind of ultimately match up, even though it's not just a purely rectangular figure. So basically this side plus 5 equals 15. So this side is going to be equal to 10. And I'm just going to put that back to black so we can see it better. Now I have all of my sides, 15, 4, 10, 9, 5, 13. So in order to find the perimeter, I'm just adding all of that up. And we don't really have formulas when it comes to perimeter, but we do need to really make sure that we get all of the sides. Okay, so if I count them, I've got 1, 2, 3, 4, 5, 6 sides. And when I'm adding up here, I've got 1, 2, 3, 4, 5, 6. So I'm just going to make sure I get all of them. So 15 plus 4 plus 10, just putting it in my calculator, plus 9 plus 5 plus 13. I get 56. Okay. But that's not my final answer because they're actually asking you how much this is going to cost if it's $10 per foot. So if you're, or not per foot, per yard. So when you're trying to calculate cost, all you really need to do is figure out how many yards you need, then multiply it by the unit price. Okay, my unit price is what they give me, which is the $10 per linear yard. So I go 56 times 10, and I get $560. And don't forget, money always needs to be written either 560 like this, or a decimal and 2 zeros. A ramp along the interstate highway is built so that trucks can pull off in case of emergencies. The ramp is paved with a special fire retardant material that costs $23 per square foot. How much will the highway department have to pay to pave the emergency ramp? So the first thing we need to figure out is, am I paying for the perimeter of something or for the area of something? And so it looks like this is something that you're going to be paving the whole thing. So, and my other hint here is that it's $23 per square foot. Square feet are that's always talking about area. So I need to find the area of this figure. And it looks like it's pretty neatly divided into just a rectangle and a triangle. So I just need to make sure I have all of my dimensions. I'll just label it 1 and 2. So 1, it's a rectangle, so it needs to be length times width. And this 60 is the full length across right here. So that's the dimension I need. And then 10 is my width here. So I've got 10 times 60. The area of my rectangle is 600. And then shape number 2 is a triangle. So that formula is 1/2 BH. So I'm going to put in 1/2 times base. Now here's where I might run into a little bit of trouble. I need to make sure that I find the right number for my base. It's not clearly labeled here. And the base of the triangle, that's this here that I'm just highlighting in blue. And so if the full length across this thing is 80, and then this top part is 60, I can find that just by subtracting. So this is going to be 20 feet. And then I also need to find the height, and that side corresponds with this other side of the rectangle. So that's going to be 10. So it looks like I've got a base of 20 times a height of 10. Okay, and then I'm just going to plug all of that into my calculator. So 1/2 times 20 times 10, and I get 100. Okay, so the total area of this thing is 700 feet squared, which that's not actually what they asked me. What they asked me is how much is it going to cost if you're paying $23 per square foot. So if that's my unit rate, all I've got to do is go 700 times that rate, and it gives me $16,100. The course designer of a Putt-a-Lot is designing a new putting green. The cost of sod is $2 per square foot. How much will it cost to put in the new green? All right, so this is asking for square feet, $2 per square foot, okay? Also, a putting green is, it's grass that's going to fill in this whole area here. So I'm looking for the area of this figure, and this one is a little bit more complicated than the last one because I've got a couple of different figures that I'm going to have to divide up. And I'm going to go ahead and divide it this way and then again over here. So I end up now with 2 rectangles and 1/2 a circle. And I need to find all of my dimensions and find the area of all these. Then I can multiply it by $2 per square foot. I'm going to go ahead and number my 3 pieces and start figuring out what I need for them. So number 1 is just a rectangle, so that's length times width. And this one's pretty easy. It gives me this 10 by the 5 are just given to me, so I don't have to do much more there. So I get 50 for that rectangle. My next rectangle, I start to run into some challenges. It's still going to be length times width. And this 20 is perfect. It's this bottom spot here. But the 15 is problematic because I cut that. So I need to figure out what the space between where I cut it and the bottom of the figure is. And luckily, I've already been given that this smaller area here is 5 feet. So 15 minus 5 means that dimension is going to be a 10. So it'll be length times width will be just 10 times 20, which is equal to 200. And now I need to find the area of this half circle. So area of a circle is pi r squared. And this isn't a whole circle, it's a half circle. So I'm going to just put divided by 2. Keep in mind on your formula chart, it's not going to have that divided by 2 part. You just need to know that that's what you have to do when you're given a half circle. So I know that the diameter of this is 10 because this other side I found was 10. So this full area is going to be 10. Okay. I need the radius, not the diameter. So I'm going to cut that in half. So my radius is going to be equal to 5. So when I write that out, I'm going to have pi times 5 squared divided by 2. And I can just put that in my calculator using 3.14 for pi. So 3.14 times 5 squared, and then divide that by 2. And I get 39.25. So that's the area of my semicircle. So now I'm just going to add up all of these, the 50 plus 200 plus 39.25, and that gives me 289.25 feet squared. So this is the area of my figure. And the last thing I need to do is multiply that by that unit rate, the rate per square foot, to figure out how much the putting green is actually going to cost. So put that back in your calculator, 289.25 times $2. And that is going to cost 578.5. And then I'm going to add another zero at the end because it's money. So 578.50 is your answer. This is the last of our composite figures for this practice test. This one is simpler than the last few. It just asks you for area. You're not calculating any kind of money or anything like that. And I can see that this one pretty neatly divides into just two rectangles. So I'm just going to split it right there. And I've got two rectangles. One is going to be 5 by 4, which is 20. And then the other, it looks like the full length across here is 8, and up above is 5. So this little spot is going to be 3. And kind of the same thing happens on the other side, is this full length across is 4, but then over here is 2. So this little side here is going to be 2. So my second shape, length times width again, is 3 by 2. So 3 times 2 is 6. And then I'm just going to add those two together, and I get 26 square inches as my answer. The last few problems that you're going to see on your test and what you saw in your practice test were just the review standard of ordering rational numbers. And I'm only going to do this one problem, but you will see a couple of these on your test. And the key with these is that you need to convert everything to a decimal. If it helps you, you may want to line them up vertically in order to really see the value of all of those. But the most important thing is converting everything to a decimal. So with fractions, just treat that like a division problem. That first one, 3 divided by 8, and that gives you 0.375. This one is already a decimal, 0.47, so I don't need to do anything. Percents, you can think of them as a fraction of that number over 100, and you can just divide it, or you can just take your decimal point and move it 2 places, and you're going to get the decimal. So with scientific notation, what happens here is you have this 10 to the negative 1. That tells you that you're going to move that decimal point over 1 spot. And because it's negative, think of it like you're making that number smaller. So it's going to move over this way. Just put it right there, and there we go. We have 38. And with really small numbers in scientific notation, you can actually put these into Desmos, and they'll give you the answer. But don't be surprised if sometimes on your test you see numbers in scientific notation that are too large or too small to just put in your calculator. So at this point, I'm going to go ahead and order them. Remember, ascending means it's going from small to big. Descending is the other way around, going from the largest to the smallest. So I just need to find my smallest one out of these 4, and it'll be my first one. And then I'm just going to go in order from there. So it looks like my smallest is 3/8. Next is this number in scientific notation, because it comes out to 0.38. So it's 3.8 times 10 to the negative 1. Next is this 0.42, so 42%. And the last one, 0.47. Okay, so on your real test, these are kind of just drag and drop kinds of things. But whatever you get as far as ordering numbers, convert everything to a decimal, and you shouldn't have any problems from there.